Mathematicians, and welcome back to our series on matrices. Today we are going to look at something very important, that is the determinant of a matrix. Okay, when we are looking at determinant of a matrix, we are going to remind ourselves with what we covered last time about the definitions or the terms that we use when we are dealing with the matrices. So at this level, we are just going to deal with the determinant of a matrix, a 2 by 2 matrix. We shall only restrict ourselves to a 2 by 2 matrix, meaning that the order of the matrix that we shall be considering is a 2 by 2 matrix. Please, if you don't know the order of a matrix, refer back to our previous videos on terms used in matrices. You'll find a definition of an order of a matrix. So today we are going to look at determinant of a matrix, but only restrict ourselves to a 2 by 2 matrix. Let's have a simple definition of determinant of a matrix. Determinant of a matrix that is now a 2 by 2 matrix is the difference between the product of the leading diagonal and the minor diagonal. Again, if you don't know the definition of the leading diagonal, please refer back to our previous videos and understand these terms because they are so important. That's why we had to define them. Go back and look at the video where we are defining the terms that we use when dealing with matrices. We have a definition for a leading diagonal and also the minor diagonal. Okay, we also called the leading diagonal, we also called it the major diagonal. Please refer back to our videos on definition of terms in this very course, then you'll be able to understand what we mean. So the determinant of a matrix is the difference of the product of the terms in the leading diagonal minus the terms in the minor diagonal, meaning that I'm going to get the leading diagonal, I get its product of the entries which are in the leading diagonal, meaning that I get the product of the entries in the leading diagonal, I subtract off the product of the entries in the minor diagonal. So that's what we are going to be doing. That's the simple definition of determinant of a matrix, and the determinant of a matrix can be denoted by det. If the matrix is A, I can say the matrix is A, meaning that the determinant, I will just denote it as determinant of A, or you can just denote it like that. So that's what we shall be looking at. Let's have a more general way of representing a matrix. Let's consider a matrix A. Let's consider matrix A, which has entries A, B, C, D, and these entries, so this is an entry in the minor diagonal, in the leading diagonal. So now, to get the determinant of A, we just say that it's det of A. You can also call it determinant of A, and you say that this is the product of the entries in the leading diagonal. These are the leading diagonal entries. So I get the entries in the leading diagonal, I get their product, meaning that I'm going to have A times D. Then remember the definition is, it is the difference between the product of the terms in the leading diagonal and the product of the terms in the minor diagonal. So I subtract off the product of the terms in the minor diagonal. So these are the product of the terms in the minor diagonal. I subtract them off. Then what I will have will be the determinant of that matrix. Let's have a very simple example on that, such that we can be able to understand what we are talking about here. Let's have an example there. Given that B is equal to 1, 3, 3, negative 2, find the determinant of B. So to get the determinant of B, we have just said from the definition above, that from this above definition, that the determinant of any number, it is the product, it is the difference between the product of the terms in the leading diagonal minus the terms, the product of the terms in the minor diagonal. So that's what we are going to look at. If we are to look at the matrix that we are given above, you are going to look at B we have a B which is 1, 3, 3, negative 2. The terms in the leading diagonal, if we are to look at them critically, these are the terms in the leading diagonal. So I get the product of those terms in the leading diagonal, meaning that the determinant of B is going to be the product of the terms in the leading diagonal, okay, minus the product of the terms in the minor diagonal. So if I'm to multiply this is going to give me negative 2 minus, this is going to be, this is a multiplication, okay? So this is going to be 3 times 3, which is 9, and I'm going to have the determinant as negative 11. As simple as that. That's what we shall be having for a matrix B with those entries. Let's have another example. Given that A is equal to PB, okay, find the determinant of A if P is that and B is that. So if we are to look at this example, you realize that we are given some things here. We are given a matrix A, but matrix A is the product of matrix P multiplied by matrix B. We are given matrix P and we are given matrix B, meaning that we are going to apply what we learned about last time, that is multiplication of matrices. So we are going to first of all multiply these matrices in order to get matrix A. Then after that, the matrix that we shall get, we get its determinant. That's what the question is asking for, that we are given A as PB, find the determinant of A if P is that and B is that. So we are going to first of all get the matrix PB. We know how to multiply matrices by now. Please, again, I'll refer you back. I'm sorry for referring you back, guys, but please, I want you to really practice these matrices. You know, it is very easy to do mathematics when you are applying it, when you are trying it. So practice the mathematics. So I will refer you back. If you don't know how to multiply matrices, please go back, watch our previous videos on multiplication of matrices, such that you'll be able to know what we are going to do here. So we are going to just multiply a matrix A is going to be PB, which is get a matrix P and multiply it with matrix B, which is 1, 3, negative 1, 0. Okay, if I'm to multiply these two matrices, I'm going to have my matrix A as a row by column. It is 2, okay, 2 times 1, which is a 2. So I'm going to have a 2 there. Then I'll have a 3. That is a positive, of course. A negative and a positive, a negative, it gives you a positive. Then I go to the other one. This is going to be a 6 and this is going to be a 0. Hoping it is clear. Then we go down. This is going to be a 0 and this is going to be a negative 5. Hoping that is also clear. Then this is going to be a 0 and this is also going to be a 0, meaning that the matrix that we shall get after multiplying is going to give us a 5, a 6, a negative 5 and a 0. So this is matrix A. Matrix A is that. So what we are left with in this case is finding its determinant, because the question is not yet finished. The question is telling us to find the determinant of A. So now I have matrix A, then I look for its determinant. Okay, so if this is my matrix A as 5, 6, negative 5, 0, the determinant, remember we said that the determinant is the product of the terms in the minor diagonal, in the leading diagonal, sorry. So the sum of the product of the terms in the leading diagonal minus the product of the terms in the minor diagonal. So if I get this product, this is going to give me a 0 minus negative 30, which is going to give me 30, meaning that the determinant of matrix A, which is equal to PB, when P is 2, negative 3, 0, 5, 1, 3, negative 1, 0, the product, I mean the determinant of that matrix, which is formed when we multiply those two matrices, is going to give me a 30. So that is also clear. Let's have another simple example. Example C, given a matrix A and the matrix B as that. Then the question is, this is the question. Now, we are given matrix A as that. We have an unknown A. This is smaller a and this is also smaller a. Those two terms are unknown. It is an unknown A which we need to find. We are given matrix A as that, and we are given matrix B as that. Then they are giving us more information that if the determinant of A is equal to the determinant of Q, this is a Q, sorry guys, this is a Q, that if the determinant of A is equal to the determinant of Q, find the possible values of A. This is very simple. What you need to do, go for the determinant of A, get it, put it aside. Go for the determinant of Q, get it, put it aside, then equate the two. Clear? Let's first of all go to the determinant of A. Determinant of A, it is the product of the terms in the leading diagonal, which is A times A, minus the product of the terms in the minor diagonal, which is negative 3 times a 0, which is going to give us A squared minus a 0, which is going to give us S squared. So that is the determinant of matrix A. Clear? Then we go for the determinant of matrix Q. The determinant of matrix Q is going also to be the product of the terms in the leading diagonal, which is going to be 4 times 2, minus the product of the terms in the minor diagonal, which is 7 times 1, which is going to give us 8 minus 7, and this is giving us 1. But the question continues to give us more information that the determinant of A is equal to the determinant of Q, implying that if the determinant of matrix A is A squared, it should be equal to the determinant of matrix Q, which is 1. Then from here, I can say A squared is equal to 1. Then I can get the root, okay? The root this side, meaning that A is going to be plus or minus 1. So the possible values of A are either positive 1 or negative 1. That is it. Meaning that we can be given an equation asking for the determinant or asking for unknowns, but we solve it using determinant of any matrix. Let's note down something before we can end this video. Let's note down something because it is very important for us. We note down something, then we do one more example, and we close this video or this lesson. Okay, let's note down something very small, and it is very crucial. Okay, matrices which have determinants as 0 are called singular matrices, and while those ones which have a determinant of any number, it can be 1, it can be 2, it can be 3, so long as this number is not a 0, then these are non-singular. Again, I'll refer you back. Go back to the terms that we use when we are defining, when we are dealing with the matrices, and review that video. It is very important. Please go back, review that video where we are defining the terms that we use when we are dealing with matrices. So any matrix that is giving you a determinant as 0, we refer this matrix as a singular matrix. Let me write it down for you. The matrices which have determinant as 0 are called singular matrices. So that is the note that I wanted you guys to know. And the reverse is true, that those matrices with the determinant which is not a 0 are non-singular matrices. So this is what we need to note down. Okay, please put it aside. If you are making some notes, please put it aside that any matrix whose determinant is a 0 is a singular matrix. Let's have an example to demonstrate that, where they can apply that not all this information here. How can we apply it in real mathematics? Okay, given matrix P is equal to 2, 4, 5, x. Okay, find the values of x if P is a singular matrix. So P is a singular matrix. What comes to your mind? By the way, let me give you a hint. Whenever you're dealing with mathematics, make sure that whenever they ask for something, try to analyze it in your head. Where can it apply? How can you apply this? How can I think of this? Like that. Then you are going to make a great mathematician. Trust me, it will come. It will come. Me, I enjoy it. Whenever I'm teaching mathematics or whenever I'm doing mathematics, I really enjoy. So please, anytime that you are doing math or you are given any question, it is put in your face. Try to understand the question. Then you can handle the question in any way you feel like. Okay, so this is the question that we're having, and the question that we are going to be dealing with, that given that p is equal to 2, 4, 5x. So this is the unknown that we're having, but more information. Find the values of x. The value of x, should be the value of x. Maybe if there are many, we shall know. Find the value of x if p is a singular matrix. Remember, matrices which have determinant as a 0 are called singular matrices. Oh my god, this is done. That this matrix, by the mere fact that it is called a singular matrix, its determinant should be 0. If it is not 0, then it is non-singular. If the determinant is not 0, then the matrix is non-singular. But so long as the determinant is 0, then it is a singular matrix. For a singular matrix, the determinant should be equal to 0. So long as the determinant is 0, then this matrix is a singular matrix. Oh my god, this is done. Let's try it out and see what we shall get. That we're having a matrix P as 2, 4, 5x. Okay, then this is a singular matrix. The singular matrix has a determinant as 0. How can I find the determinant of this? The determinant of P is equal to the product of the terms in the leading diagonal, or the entries in the leading diagonal, okay, minus the product of the entries in the minor diagonal, which is 5 times 4. So I get this as 2x minus, this is going to give me 20. So it is 2x minus 20. But this is a singular matrix, meaning that the determinant of P should be equal to 0. Therefore, 2x minus 20 is equal to a 0. 2x is equal to 20. Then x is going to give us 10. Wow. Therefore, the value of x for the matrix that we are having as P is equal to 10, so long as it's a singular matrix. Guys, please subscribe to the channel. Let's stop here, come back, hit the notification button just here, okay, and also turn on the notification. Thank you very much for watching. Catch up with you guys for the next lesson.